next-generation thermoelectrics designed for real-time PCR. Polymerase chain reaction, or PCR, is used within molecular diagnostics to amplify segments of DNA. The actual PCR process is enabled by a thermocycler that utilizes thermoelectric technology to rapidly cool and heat samples. This is a harsh environment for standard thermoelectric coolers, as the rapid temperature changes cause mechanical stresses on the devices. Laird Thermal Systems' PowerCycling PCX series is designed to handle hundreds of thousands of thermal cycles, providing precise temperature control and faster ramp rates for PCR applications. There are three main types of PCR: traditional, real-time, and quantitative or digital PCR. While traditional PCR machines provide test results after the thermal cycling is complete, real-time PCR allows technicians to view results in real time. This allows them to stop the test and restart if they find something erroneous with the data. Quantitative or digital PCR provides an exact count on rare DNA sequences, which allows for a deeper analysis than what can be detected with real-time PCR. Typically, PCR requires a series of 30 to 40 thermal cycles to create up to 1 billion DNA strands. The first step of the thermal cycle temperature is increased to 95 degrees C in order to separate the DNA strand. The temperature is then lowered to a melt temperature between 50 to 65 degrees C, at which biomarkers bond to the DNA. Finally, the temperature rises to 72 degrees C so a copy of the DNA can be sequenced. Temperature set points and time applied for each step depends on various parameters based on how well the biomarkers attach to the DNA. It is also important to keep the temperature set points to within plus or minus 0.5 degrees C to assure precise sequencing replication. On advanced PCR machines, a pre-trial test can be run to find the optimal melt temperature that biomarkers bond to DNA, which is typically somewhere between 55 to 65 degrees C. The melt temperature can be determined by analyzing samples in real time, at set temperatures created by temperature zones across the sample well cartridge. PCR thermocyclers utilize thermoelectric coolers because they offer more precise temperature control and faster ramp rates compared to conventional thermal technologies, such as heaters and fans. Thermoelectric coolers must maintain precise temperature control to within plus or minus 0.5 degrees C for the 96 or 384 well sample trays. To minimize temperature gradient across the tray, a highly thermally conductive cold plate and interface material is required, especially in the lateral direction. The heat rejection consists of a heatsink and fan. A resistant heater is typically incorporated into the hot side heatsink with a secondary control loop to temperature stabilize the hot side, while the control side is fluctuating across a plus 45 degrees C temperature differential. This will help minimize overshooting of temperature set points under fast ramp rate conditions and reduce thermal cycling stress on thermoelectric coolers. In addition, thermoelectric coolers must have tight lapping tolerances to minimize the air gap when coming in contact with mating surfaces of heatsink and cold block. This assures good contact when a thermal interface is applied and will help minimize temperature gradient. The AC resistance, ACR, of a thermoelectric cooler may degrade slightly over time. This can impact the temperature gradient as the ACR of each thermoelectric cooler will have a different nominal ACR. It is therefore recommended to group thermoelectric coolers in sets to tight ACR tolerance for each PCR machine. Thermal cycling exposes thermoelectric coolers to mechanical stresses as the module contracts and expands from repeated heating and cooling cycles. This can quickly degrade the long-term performance and operational life of a standard thermoelectric cooler. Meeting demands of PCR applications, the PowerCycling PCX series features a flexible thermally conductive soft layer which absorbs the mechanically induced stresses and extends the overall operational life of the thermoelectric cooler. Assembled with next-generation thermoelectric material, the PCX series delivers faster ramp rates compared to standard thermoelectric coolers, resulting in greater throughput and faster test results. This series has been validated to withstand rapid thermocycling test standards of leading PCR OEMs, and by extending the mean time between failure, MTBF, it offers lower total cost of ownership. The module is built with robust construction and enhanced process controls to operate in temperatures up to 120 degrees C, exceeding PCR application requirements. The PCX series is offered in a wide range of cooling capacities ranging from 14 to 215 watts and many footprint configurations. By installing elongated thermoelectric coolers under the PCR well tray, temperature zones on the PCR can increase, making it easier for the technicians to find the optimal melt temperature. Elongated thermoelectric coolers are typically challenging to manufacture due to the bowing effect that comes with longer parts. Through enhanced proprietary process controls and advanced thermoelectric materials, Laird Thermal Systems has developed an elongated series of PCX Thermoelectric Coolers that eliminates this effect and provides high reliability for thermal cycling applications. PCR Thermocyclers utilize Peltier technology to precisely manage set point temperatures and ramp rates. Standard thermoelectric coolers cannot withstand the mechanical stresses induced by rapid temperature changes in these environments. The enhanced PowerCycling PCX series from Laird Thermal Systems offers precise temperature control at faster ramp rates to significantly improve and speed up PCR testing. The highly reliable PowerCycling PCX series extends the mean time between failure, MTBF, of thermocyclers to reduce maintenance and downtime, lowering the total cost of ownership and allowing its customers to sell more consumables over time. Visit LairdThermal.com to find your optimal thermoelectric cooler and learn more about how the PowerCycling PCX series can improve PCR testing. Laird Thermal Systems develops thermal management solutions for demanding applications within medical, analytical, industrial, transportation, and telecom markets. If you have questions or need more information, please chat with us via the website at LairdThermal.com.